In this video, we will focus on projectile motion applications of quadratic functions, quadratic equations. A rocket is fired upwards from the ground with an initial velocity of 100 feet per second. The height y of the rocket at any time t is given by y equals negative 16t squared plus 100t. So there's two parts to the problem. In part A, they're asking us to find the height of rocket after 3 seconds. And part B, find how long would it take the rocket to be on the ground. So to find the height of rocket after 3 seconds, we will simply replace the time t by 3. So plug t equals 3, and we would get y equals negative 16 3 squared plus 100 times 3, which is negative 16 times 9 plus 300, which is negative 144 plus 300, and that's 156 feet. So rocket is at height 156 feet after 3 seconds. Okay, after 3 seconds, the rocket is at 156 feet height. Now for part B, we are looking for how long would it take the rocket to be on the ground. So when the rocket is on ground, what is going to be the height? The height is going to equal 0 when the rocket is on the ground. So I'm going to replace the height by 0 in the equation and solve it. Let's replace the height by 0 and solve it. So 0 equals negative 16t squared plus 100t. Let's see if there's a common factor. I can see there's a common factor of negative 4t. You don't have to pull out the negative, but you can if you want to. So I pulled out a negative 4t. Inside, I would have 4t minus 25. So zero product property says if product of two factors is 0, one of them must be 0. Either negative 4t is 0 or 4t minus 25 is 0. So this gives me t equals 0 because 0 divided by negative 4 is still 0. And this gives me t equals 25 over 4. So there's two answers, 0 seconds and 25 over 4 seconds. So 0 seconds is when the rocket actually started, when we shot it upwards, and 25 over 4, you can change it to decimals if you prefer. 25 divided by 4 would be 6.25. So you could write it as decimals or exact answer is fine. So now the question they were asking was, how long would it take the rocket to be on ground? So it is actually going to take 6.25 seconds because 0 seconds is when it actually started. Okay, so 6.25 seconds or 25 over 4 seconds. That's to be exact. Let's look at another example. A diver jumps directly upwards from a board that is 32 feet high. The function, luckily the function is given to us. When you get to calculus, you have to develop your own, you have to come up with the own function as well. So this function gives the height t seconds after he jumps. So this function gives the height t seconds after he jumps. Find the height of diver after 1 second and then after 2 seconds. I'm only going to do one part. So after 1 second, the height would be, we would have to replace the t by 1. If you want to find the height after 10 seconds, we will replace the t by 10. If you want to find the height after 7.5 seconds, we will replace the time by 7.5. Okay, after 1 second, the height would be f of 1, which is negative 16, 1 squared plus 16 times 1 plus 32. Now this f of 1 or this f of t simply means the height f is a function of time. We're not multiplying f and t together, okay? It's just evaluating the function at that value of t, which is 1 in this case. So it turns out to be negative 16 plus 32, which is 32 feet high. So the diver will be at 32 feet height after 1 second of jumping. And you can do part B similarly. Let's check out another example. A baseball is thrown straight up from the height of 64 feet. The function, so here's the function given to us, describes ball's height t seconds after it is thrown. So this function gives the height s The height is S in this case, T is the time. So height is labeled as S, time is labeled as T. How long will it take the ball to be at 64 feet again? Okay, so there's two parts to here. We're wondering, the ball is thrown up from a height of 64 feet. The function is given here, and we're wondering how long would it take the ball to be at the height of 64 feet again. So we're trying to figure out the time when the height is 64 feet again. So I'm going to replace the height by 64 into the equation, because that's what, let's rewrite the equation quickly. So S of t is negative 16t squared plus 48t plus 64. So the height is 64, negative 68t squared plus 48t plus 64. Okay, we're going to go ahead and subtract 64 from both sides. We're trying to solve this equation because it's a quadratic equation and I want to get a 0 on one side. So we'll be left with negative 16t squared plus 48t plus 64 minus 64, which is gone. So 0 equals negative 16t squared plus 48t. Now, is there a GCF in this case? Looks like negative 16t will be a GCF, and t minus 3 will be what we're left with when we undistribute negative 16t. All right, so now your zero product property says plug each factor equal to 0, negative 16t equal to 0, and t minus 3 equal to 0. So we will divide both sides with negative 16, there's 0. So that's when it actually started. That's what it says, that in the beginning it was at 64 feet. Now solving the other factor, plugging it equal to 0, we get t equals 3. That means after 3 seconds, that is going to be our answer in this case. After 3 seconds, the ball is at 64 feet again. So we would write down after 3 seconds. After 3 seconds, ball is at 64 feet again. So it was at 64 feet at 0 seconds when we shot it upwards, and then after 3 seconds it was back to 64 feet. All right, next question, part B. How long would it take the ball to hit the ground? So when the ball hits the ground, the height is going to equal to 0. So for part B, when the ball hits the ground, the height will be equal to 0. So that means I'm going to replace the height by 0 when the ball hits the ground. So 0 is equal to negative 16t squared plus 48t plus 64. And to make my life easy, I can factor out a negative 16 out. GCF, negative 16 is the GCF in the whole equation. T squared minus 3t minus 4. And we can go ahead and divide both sides with negative 16 now. So we're just left with t squared minus 3t minus 4 equal to 0. Let's go ahead and factor this. Two numbers, they multiply to give me negative 4. They add up to give me negative 3 are negative 4 and plus 1. Those will be my special numbers. Now when I plug each factor equal to 0, so I get t equals 4 and t equals negative 1. Time is never negative, so this is not an acceptable answer. And we will be only left with t equals 4. So after 4 seconds, ball will be on ground. Ball will be on ground after 4 seconds. Okay. After 4 seconds, ball will be on ground. After 4 seconds, ball will be on ground. Time is never negative. Also think about the negative 1. That means when the time was 0, when we actually shot it up, we were at 64 feet height. So it happened sometime before that, it was on the ground. And that's not going to be our answer because time is never negative. Time is always positive. Time and distance are always positive. Next example, the width of a rectangle is 7 feet less than its length. Find the dimensions of rectangle if the area is 78. Okay, so let's think about the width. Let me draw a rectangle really quick. We don't know the width, we don't know the length either, but we do know the width is 7 feet less than the length. So if I say the length is x, the width would be x minus 7. And I'm being told that the area is 78. So I'm going to say let the length be x, width will be x minus 7, and they both will be feet, and we can take care of the units at the end. So now set up the equation. How do you find area of a rectangle? Area of rectangle is length times the width. So x times x minus 7 is equal to 78, and let's go ahead and do the distributive property. X times x is x squared. X times 7 is 7x equals 78. Quadratic equation. We need to bring everything to one side and go ahead and start solving this quadratic equation. Now we're thinking about two numbers. They multiply to give you 78 and they add up to give you 7. So what would be the two numbers? They multiply to give you 78 and add up to give you 7. Go ahead and pause for a minute and try figuring out those two numbers. And if you have a hard time figuring those numbers out, you can always go ahead and write down, you can always start making a table. So here you can do, okay, 1 times 78 is 78, but we cannot add or subtract them to get a 7 out of it. So that's not going to work. 2 times what gives you 78 is 2 times 39, which is not going to work out either because they're not going to give me a 7 when I add or subtract. 78 does not divide with the 3. Does 78 divide with the 4? 78 does not divide evenly with the 4, not with the 5. How about 6? What times, or 6 times what number gives you 78? That is going to be 13. And is there any way I can get a 7 out of it? Yes, if I make 13 negative and 6 positive, they will multiply to give me negative 78, and they will add up to give me negative 7. So negative 13 and positive 6. Negative 13 and positive 6. So my factors are x minus 13, x plus 6 equal to 0. There we get the two answers. X equals 13 and x equals negative 6. And the length or distance is never negative. So is the time. They're always positive. So we're going to disregard the answer x equals 6. We'll go with x equals 13. So they were asking us to find the dimensions. That means at the end I'm going to have to tell them, well, the length is 13 feet and the width is 7 less than that, which will be 6 feet. And there's my two answers here.